Hello all, in today's video we are going to see about basics of image processing. So install Anaconda OpenJupyter notebook and do the following steps. So first of all, install the OpenCV using the command to install OpenCV-Python. After that, import the necessary files, import the necessary packages or libraries. And this function, it is download and unzip, is a user-defined function which will unzip the downloaded zip file. So I have printed os.getCwd, which is the current working directory, which is C users some name, and this is the location, this is the file name, OpenCV bootcamp assets nb1.zip. It is having set of the images and it will be downloaded and it will be automatically unzipped using this function. Okay, this is the function called download and unzip of the URL and the asset zip path. The URL is nothing but actually having the directory which is having the images, and asset zip path is nothing but the current working directory where the downloaded file has to be kept in the PC. Okay, so this command and after that you can check the following images are available in the working directory. C uses the name, right? So here you can check. We are having so much of images: checkboard 18x18, checkboard 84x84, and checkboard color, Coca-Cola logo, and New Zealand lake. We are going to process these images one by one. So you can display the image file using the function image of file name equal to the checkerboard underscore 1818.png. So you can see the extension as png here. So the image name is given here. You could see the image, right? So next I'm going to display another image, 84x84.jpg. So this is the file 84x84 JPEG. So the image of function will display the file, and I have displayed checkerboard color.png file also. And next we are going to read the images grayscale. So we are having three values, 0, 1 and -1. So and here we have just displayed the images without using any CV packages or CV functions. Here we are going to use imread, which is nothing but a built-in function available in CV2 package. So cv2.image of the image to be read, and 0. 0 indicates the images will be read in grayscale, not in the colored one. It will be only in black and white, not in any colors. So 1 is a default value, which is RGB. The actual image color will be represented. -1 is nothing but an alpha content. It will remove the transparency and all. So now the image is read and stored in the object CB underscore image. So if we are printing CB underscore image, we will see the values in 0 and 255. 0 and 255 means it is only black and white. If there is any values in between 0 to 255 means it is a color of any combination of red, green and blue. And since it is a 18x18, so we are getting the image in 18x18, and we have read the images as 0, which means a grayscale. Only the black and white colors are available here. And I'm going to read the second image, 18x18, in the 1. 1 means the normal color. The normal color itself is a black and white, right? We have found 18x18 is again a chessboard, so it is black and white. If it is some other color means we will say some other different values. And -1, the same, it will remove the transparencies only. So similarly, I'm displaying all the images with the different values, either grayscale or normal color or alpha channel values. The next attribute we are going to see is cb underscore image dot shape and d type. Shape means the dimensions of the image, and d type is nothing but the data type. So here you can see cb underscore image is nothing but checkerboard 18x18.png in 0. 0 means only black and white, not RGB. So we are having only two dimensions. One is W and H, height and width of the image. And we are going to display the image using the function imshowOff. imshowOff will display the image using this IM show is a method used to display the image. The name of the image, that is CB underscore image, which is nothing but checkerboard 18 cross 18, which is displayed here. And you are seeing the color as yellow and violet. It is not black and white, so we'll see that later why it is displaying in this color. So next we are going to print the checkerboard PNG. So I'm going to first read the image. I'm going to read the image in 0. 0 means it is a grayscale, and storing it in a variable img2. I'm printing this as im show of img2. So here you are seeing some other color. Previously we have displayed the image in some other different colors. Here we are displaying in the different color because we are reading the images in grayscale. So the original color of the image will be converted. Thus black and white is represented here in the form of some blue or maybe green or dark blue, something like that. Because in order to show the difference between the each boxes, the black and whites are represented in this way. So we have to represent it in grayscale, means we have to represent. So here the image name is img2. If you want to represent in gray means we have to represent CMAP equal to gray of, which will display only the black and white. So based on the color variation, the color cells will be somewhat darker, right? So yeah, similarly we can represent each image in gray. Okay, next I'm going to load the image coca-cola.png. So it is displaying. So here we haven't used any CV2 function. Here I'm going to read the image using CV2. And after reading the images, I'm going to print the shape and detail. In this we have used the dimension as 1, which means it is reading it in regular RGB mode, not in black and white. So the dimension is 700, 700 and 3. Previously we have seen only 2 values. Now we are seeing 3 values. Now let's display IM show of Coke image. What is displayed? The red color is displayed as blue because by default CV2.img function will read the image in reverse format. The regular format of the image is RGB, that is red, green, blue. But imRead function will read the image in BGR format. So it is reversed. So we are getting the blue color instead of red color. So in order to print the original image, always we have to reverse it. We can reverse it using the slice operator colon, comma, colon, comma, colon, colon, -1. And we are storing it in a variable named reverse. Now let us display the image using im show of function will display the original color. So we have to keep in mind that imRead will always read the image in the format BGR. If you want to display it in the original format, we have to reverse it using the colon slice operator. Okay, next we are going to read the New Zealand Lake package, and we can give either 1 or imRead underscore color. Both are same. imRead underscore color is also equivalent to the value 1. I am just displaying it. Now see the original image. I am going to open the New Zealand. Okay, sorry, this is not the original one. Yeah, this is the original one. New Zealand Lake original image is this. What we have read is actual RGB color, but we are printing it. It is showing in some other different color because it is read in BGR format. If we are reversing it and then printing it, it will show the original image. So next we are going to see about split and merge functions. So initially I have read the image in IMG NZ BGR. So I am going to split it and in a format of BGR. So we are going to split in 3 components. Originally it will be in BGR. So the first will be B, second will be G, and then will be R. So the blue component we are getting some other values. So you can see the difference. If it is RGB means we will have some values between 0 to 255. If it is not RGB, if it is grayscale means we'll have only black and white. So the values will be only 0 and 255, not any other values. So if you found any values other than 0 and 255 means it is a colored image, not a grayscale image or black and white image. So I'm just printing BGR values, and I'm going to set the image size as a dimension 20 cross 5, right? Height of the image is 5 and 20 is the width of that, right? And I'm going to create a subplot of 4 divisions. 141, subplot of 141 means 1 indicates the number of rows. This is the rows. Assume that this is the rows. I'm having only one row here. And how many columns I'm going to have? 4. 1, 2, 3, and here the fourth one is empty. It will be occupied later. And 1 indicates that like an index. Okay, this 1 is the first part, this 2 is the second part, and this 3 is the third part, right? So 141, which means first row, totally 4 columns. Out of 4 columns, I'm going to occupy the first one. So which means this part. I'm going to give the title as red channel. What I'm going to print? I'm going to show only the R, that is also in gray color. Only the red component, only this red component part will be displayed here. Similarly, the G component part will be displayed here. B component part, that alone in gray, will be displayed. So I'm going to remove the gray, which means it is in some other format but not the original color, right? I'm going to merge it. I'm going to merge it again, BGR, into a single form. After merging it, I'm going to place it in a fourth plot. Okay, I'm going to place it in fourth plot, which means first row, fourth column, and fourth spot, and I'm going to reverse it, and then I'm going to place it. If you are not reversing, means you will get the output like this. Okay, so we are going to reverse it, and then we are going to place. So you can remove the red channel, green channel, blue channel, and you can process it according to the need, and you can merge it using the merge function, and we can reverse it, and then we can display it using the IM show off function, right? Next, CVT color. The CVT color is used to convert BGR into RGB, and we can perform HSV, right? Hue, saturation, and some other things, right? Okay, then we are going to convert BGR into RGB. So CVT color function is used to convert the colors from BGR to RGB. Again, we can perform BGR to HSV. After converting the BGR to HSV, all the values will be converted to HSV only. So if we are performing any split operation, the HSV value will be stored here, and we can similarly we can print the H channel, S channel, V channel, and we are printing the original images. We can improve the hue, we can improve the saturation according to the need of the work. Okay, and after improving the hue by 10, I'm going to merge, and you can see the image difference here, right? So the next part is converting the HSV to RGB. So BGR to RGB, BGR to HSV, HSV to RGB, any other combination of conversion is possible. So I'm going to convert HSV to RGB. So here I have increased some of the hue value, and then I'm converting into the RGB. Now I am printing it. Okay, so these are some of the process of increasing or decreasing the particular part of the value and its images. Okay, so here finally we are saving the images using the function IMWriteOff, and the file name, what is the name of the file to be written, and what is the image to be stored here, and finally I'm just printing it using image of function. This is the final image. So you can see the image will be available in the location what we are working on. Okay, so that's all. Thank you.